So I'm going to tell you today why I'm so excited about Svelte as a web app framework. And many of you know that I wrote a book on this last fall. So you see that in the upper right corner there. And you can find these slides out at my GitHub repo in a repo called Talks. And I'll show you what that looks like now. So here's my GitHub repo. And you see I'm in Talks, and there's a directory here called Svelte. And inside there are a bunch of presentations, but the one that you're looking at now is this one that says Svelte Go To. That's because I presented this at a Gotopia or Go-To-topia, however you pronounce it, conference earlier this week. And so those are the slides that you want. So Svelte is an alternative to other web frameworks that you're probably familiar with, like React and Vue and Angular. But one thing that makes Svelte really different is that it's a compiler. It's not just a library of code. And what that means is that you implement your components in files with a .svelte extension, and that gets compiled into JavaScript. And so Svelte doesn't have any runtime dependencies. It just has dev dependencies for developer tooling. And so the JavaScript that gets generated is just the parts that you actually need to run your app based on the features that you're actually using. It doesn't use a virtual DOM, and so this makes it different than React and Vue. So for those of you not familiar with that concept, basically the virtual DOM says, I'll make an in-memory representation of everything that is on the page, and then when you change something, I'll make another in-memory representation, and then I'll do a diff between the two and figure out what really changed. And then I'll just update those parts of the DOM. There are several problems with that. One is just the size of the code that has to get downloaded to the browser. That is the implementation of the virtual DOM, the code to build it, the code to do the diffing. And then another is just the time required to do that. And so you might wonder, well, couldn't the web framework just observe what I'm changing and know what parts of the DOM might need to be updated? And that's exactly what the Svelte compiler is doing. It's generating the code to kind of surgically update only the parts that need to be updated based on the changes that you're making in your code. And so it's way more efficient. And it also results in you having a smaller amount of code that has to get downloaded to the browser, which makes your web app start up faster. So this was created by Rich Harris, who used to work at The Guardian and now works at the New York Times. He's a graphics application developer there, and he uses Svelte in his work there. Previously, he developed a web framework called Reactive, and he used lessons that he learned in building that to build Svelte. He also created the Rollup module bundler, which is a very popular alternative to Webpack and Parcel. And so he's got a lot of experience working in the open source space. SvelteKit is a framework that sits on top of Svelte. There was a thing similar to this before. It still exists. It's called Sapper. That's a part of what I cover in my book. SvelteKit is just a re-implementation of that. In fact, most of the ideas are the same, just implemented slightly differently. Some of the names have changed, but the concepts are all still there. And so I'll talk about what this adds to Svelte, and then we'll get into what is really a core part of Svelte. So one of the things you don't get with Svelte out of the box is a way to do page routing, where you want to say if the user navigates to a certain URL, or if I have a link in my app that goes to a certain URL, that means I want to render a certain component. So that's what I mean by file-based page routing. And SvelteKit provides a really nice way of doing that. You just drop components in a certain directory, and it uses their name as the part of the URL that would indicate that you want to render that. So it's really easy to set up page routing with SvelteKit. Then it also has file-based endpoints, which are implementations of REST services. And you're not required to use this for REST services consumed by a Svelte app. It's just an option if you want to use it. You always can implement your REST services in another language, like say Go or Java or C# and call those from your Svelte web app. But with this approach, what you do is you create a directory underneath the routes directory, and the name of that directory is really a part of the path to your REST service. And then you create a JavaScript file in that directory that defines functions like get and post and put and delete. And that is the implementation of your REST service. And so in your one project, you can implement both the front end and the back end. Layouts are a way to say that in my app, I have a common header and footer on all my pages. Maybe I have a common left nav, and you can define what that layout is like. And then as you navigate to different pages in the app, they fill in like the center part of that layout. You can define an error page. So if something goes wrong, for example, an error comes back from a REST service call, you can have a page that gets displayed to tell the user about that error. It gives you code splitting for JavaScript and CSS. And so what this means is that rather than saying when you hit a web app, you have to pull down all the JavaScript needed for the whole app and all the CSS, you can make it so that you just pull down what you need for that first page. And then if you visit another page, then it pulls down the JavaScript needed for that. And of course, it's caching it. So if you visit a page a second time, it doesn't have to pull it down again. But the result of this is that your first page load is way faster because you're just pulling down what is needed for that page. Hot module reloading is very useful in development. It's making it so that if you make a change to a component, it can recompile just that component and load that changed JavaScript in the browser and show you the result of that. Without using Vite as the way to get hot module reloading, what Svelte was doing was compiling everything and creating a new bundle of all of the JavaScript and then loading that into the browser. But with this approach that relies on ECMAScript modules, it can just compile a single component and just update the JavaScript or the CSS for that one component. And so it makes iterative development really fast. SvelteKit allows you to say, this app I'm working on is really static in nature. And so at build time, I want to generate HTML for the whole thing, or to say that only certain pages in my app are static and the rest needs to be dynamic. Also, SvelteKit helps you with setting up a bunch of tooling. So if you want to use TypeScript or a CSS preprocessor, or you want to use ESLint for checking potential issues in the JavaScript code, or you want to use Prettier for formatting the code, SvelteKit will set all of that up for you. And then the last feature I want to mention is adapters. So SvelteKit bills itself as a serverless first platform. And what they mean by that is they want to make it really easy to deploy your app that makes use of serverless functions. And so it's just a matter of setting the configuration to tell it that I want to use a specific adapter. So for example, I can say, I want to use Netlify. And then when I build and deploy my app, those file-based endpoints that I talked about earlier, those will get deployed as serverless functions for me. And I do almost no configuration to get that to work. And in fact, Netlify is actually deploying them to AWS as serverless functions, and you don't even have to know anything about AWS, it just works. So in the blue boxes, I have a list of some of the important files to look at, but in the interest of time, I'm going to go by that. And let's talk about how to get started with using SvelteKit. And I should mention that SvelteKit is in beta right now, and so possibly you don't want to use it yet for a production application. But if you're not releasing for a few months, maybe it is safe to go with this now, just knowing that there could be some breaking changes still. So you can use vanilla Svelte if you'd like, or what I'm showing here is to get started with SvelteKit. So you see the npm init command to tell it I want to use the next version of Svelte, which is SvelteKit. And it's going to ask me a bunch of questions. So it asks me if I want to use TypeScript, do I want to use a CSS preprocessor, do I want to use ESLint, do I want to use Prettier? And all those boxes off to the right are just my suggestion for how I like to configure all of those tools. Then I cd into the directory that it created for me and run an npm install to install all of the development dependencies that I need. And now I'm ready to run things. So I can run ESLint to check for issues with npm run lint, or npm run format to run Prettier. And then if I want to run the code in development mode, which is what I'll spend most of my time doing, it's npm run dev, and that gives me watch and live reload. So I can change a component in the app and that'll get compiled and loaded in the browser automatically. then there are a couple of options I can specify. So --open means I want it to not only start my development server, but also open the app in my default web browser automatically for me. And I could tell it to run on a different port, which defaults to 3000. When I'm ready to deploy this, I run an npm build and it puts a bunch of files in a build directory, and that's what I need to deploy. So let's take a look at an example of what the code looks like when you work with Svelte. This really is, for me, the main benefit is that the code is easier to understand and I can write less code. So I'm going to walk through the classic to-do app, and I have URLs for a couple of GitHub repos there. The first one is actually the code we're going to walk through. And then the second one is a work in progress where I'm expanding this to have user accounts, and every user has their own list of to-dos and authentication and all of those things. But let's focus on the simple one right here and just get a feel for some of the benefits of using Svelte. So this is the app that I want to build. It's just a to-do app. I can type in new to-dos and they appear in my list. Each row in my to-do list has 3 things in it. There's a checkbox, so I can tell it whether I've completed that to-do, the text of the to-do, which gets a line through it when I've completed it, and then a delete button for getting rid of it. Once I've completed a bunch of to-dos, if I just want to archive all of them, I can click the Archive Completed button at the top. And you see how it's giving me a status to the left of that Archive Completed button. It tells me how many total to-dos there are, and out of those, how many have I completed so far. So I'm going to jump over to the browser and demonstrate this for you. And so here's the app. And so I can type in new to-dos like get milk, cut grass. And then if I select one to say it's done, notice that the text changes to gray and I get a line through it, and I could uncheck it. Okay. And now if I hit archive completed, it's going to get rid of those for me. Notice right now it says 2 of 4 remaining, but now when I archive, there's 2 of 2 remaining. So that's all the functionality that we want to walk through. And so going back to the slides, the part outlined in red here, that is a to-do component. And then the top level component really describes the rest of the app. So let's start by looking at just the to-do component. So a Svelte component can have 3 sections to it. There's a script section where you have your JavaScript code. Then there's the HTML that you want to render, and then the CSS that defines how you want to style it. So one thing to notice about this component is that there's some things that you can do that it doesn't really know how to handle. So for example, when I want to click the checkbox to toggle the state from not done to done, this component doesn't really know what to do, but the parent component does. And so to let the parent know that that has happened, I'm just going to dispatch an event, and it's going to be listening for that toggle done event that you see on line 12. Similarly, this component doesn't know how to delete a to-do, but it can dispatch a delete event like you see on line 15 and let the parent component handle it. So going back to line 2, I'm importing create event dispatcher because I need to call that to create the dispatch function that I call on lines 12 and 15. I'm going to do some animation here as well. That's a thing that Svelte makes really easy to do. So you see that on line 3, I'm importing the fade transition, and then I'm using that on line 8. And so what that means is that when that list item on line 8 gets added to the DOM, it won't just jump into view, it will fade into view gradually. And when it gets removed from the DOM, it will fade out of view gradually. So it's so easy to add these animations in Svelte that it kind of encourages you to make the UI look a bit nicer by adding those. Line 5 is defining a prop for this component. So that's a way that data can get passed into a component. And the key here is that it uses the export keyword. Remember that this is in a .svelte file, and so the Svelte compiler can choose to interpret things maybe a little differently than JavaScript would, and this is one of those cases. So the Svelte compiler, when it sees a line like 5, it says, oh, you're telling me about a prop that can be passed in. So in this component, a to-do is an object that has 3 properties. It has a unique ID, it has the text of the to-do, and then it has done, which is a Boolean. So now we're ready to look at the HTML that this is going to render. So we saw that we have a list item, and then there are three things inside it. There's the checkbox, there's a span tag that holds the text of the to-do, and then there's that delete button. The checkbox is going to start off already being checked if to-do.done is true. You see that on line 11. And then on line 12, we set up the event handling. So anytime the state of the checkbox changes, I'm going to dispatch a toggle done event. And I'm just hoping that my parent component is listening for that and takes the appropriate action. On line 14, I'm showing the text of the to-do, but I also want to assign a CSS class to this that is either going to be done-true or done-false. And you see on line 19 that we have special styling if it's done-true, and that is that I want the text of the to-do to be gray, and I want to draw a line through it. And then the delete button is just dispatching the delete event. So one interesting thing to notice about this component is that nowhere in this code do I say what the name of the component is. And in a sense, it doesn't have a name. It's not until you import this in some other component that you assign it a name. And we'll see that on the very next slide where this gets imported. So look at line 2. That's importing the code that we just looked at. And here's where I'm saying I want to call this to do when I refer to it inside this file. So this is the topmost component of the app. And there are 3 sections just like the previous component, but they're a bit longer. And so on this slide, we're just looking at the JavaScript for the to-do app. So I need to be able to create new to-dos, and they need to have unique IDs. And so line 4 is where I keep track of the last ID that I have assigned. And then on line 5, I've got a function defined with an arrow function that I can easily create a brand new to-do object. And remember I said that those to-do objects have 3 properties. There's a unique ID, there's the text, and there's done. And so what I pass to this function is just the text and optionally whether it's already done. If I don't pass that, it will default to false. And then I just bump up last ID by 1 and use that as the ID of this to do, and then use the text and the done value. The state of this component is really the text that you can type into the input for creating a new to do. And it's an array of to-dos. And an interesting thing about Svelte is that the state of a component is the value of the top level local variables. And so for this component, that's 2 things. They're on lines 7 and 8. So those variables are the state of this component. If you were doing this in React, this is where you probably would use the use state hook, but you don't need to do something like that in Svelte. It's just a variable. For demo purposes, I want to start by already having 2 to-dos. And so I'm calling create to-do twice. So learn Svelte as a to-do, that's already done. And then build a Svelte app, that one is not done. Lines 13 and 14 are reactive declarations. And I know that because they begin with $:. So this is a special thing that the Svelte compiler supports, where it uses what is a JavaScript label for a different purpose. And so essentially $: is just a label whose name happens to be $. And what that means to the Svelte compiler is that if anything referenced in this expression changes, I want to run that line of code again. So for line 13, that means that if the array of to-dos changes, I need to run that again. And so all it's going to do is filter out the to-dos that are not finished. And so now I have a list of just the ones that are not done. And then I want to count them. I want to get the length. And I want to take that value and put it into the variable uncompleted count. Line 14 says if to-dos changes or if uncompleted count changes, I need to run that line of code again. And it's going to build up a new string. So the backticks there, that's a template literal in JavaScript. And so it just replaces the expressions inside the $curly brace parts and builds a new string for me. And so now I can use uncompleted count and status in what I'm rendering. And I know that those are going to automatically update anytime a value that they use changes. This is very much like using spreadsheets where you put a formula in a cell of a spreadsheet, and you know that if that formula references another cell and that other cell changes, it's going to recompute the value of that formula and update what you see in that cell. That's really the same thing that's happening on lines 13 and 14. Then we just have some plain JavaScript functions to take care of all the functionality that I need here. So one piece of functionality is to add a new to-do. And we'll see coming up that anytime the user types input into where they can describe a new to-do, it's going to modify the value of to-do text. So when add to-do is called, I know that that already has the new value. So I just pass it to create to-do to make a new to-do object. And then I concatenate that onto my array of to-dos and assign it back to the to-dos variable. That's important for Svelte to know that that has changed so that it can trigger lines 13 and 14 to run again. Also, after you add a to-do, it's good to clear out the to-do text like I'm doing on line 18 so the user's ready to type in another one. Archive completed, well, in a fancier implementation, I would be persisting these out to a database. But in this simple version, really what I'm doing is saying, I only want to keep the to-dos that are not done. So I do that filter and assign back to the array of to-dos. If I want to delete a specific to-do, I will be passed the ID of the one to delete. And then once again, I'm going to filter my array of to-dos, and I'm saying here that I want to keep all the ones that are not the one I'm trying to delete. And then finally, toggle done, I'm passed a to-do object and I want to toggle its state. So I'm going to use the map method on the to-do array to look at every one of the to-dos, and that ternary is saying, if this is the to-do that I want to toggle, then what I want to do is create a brand new object. So look at the curly braces after the question mark there. And the ... says, I want everything that is in that to-do object. But then after that, I'm saying, I want a different value for done. I want to change it to not what it was before. Okay, and then the colon, and then this just T by itself here says, well, this was not the to-do I wanted to toggle. So just keep the object the way that it was. So an interesting thing to notice here is that all this functionality is implemented with plain JavaScript functions. There's no classes or methods, and so I don't have to worry about the this keyword to try to understand how that works in JavaScript. It's all very straightforward JavaScript functions. So that's the JavaScript portion of this component. And now here's what I want to render. And so if you remember back to that UI, in fact, here it is. So this is all that we want to render. So the first thing is that we want that heading at the top that says to-do list. And then I need to display the status. That's where it said 1 of 2 remaining. And remember, that gets updated automatically anytime the uncompleted count changes or anytime the to-dos array changes. Then I've got my archive completed button, and we see some event handling on line 5. So if I get a click event, I want to call the archive completed function. Then I've got a form where the user can type in text for a new to-do. And when they submit the form, either by clicking the add button on line 15, or if they just type something in the input and hit the enter key, either way, that's going to trigger a submit event on the form. And so on line 7, I'm saying I want to prevent the default form submission. That's the prevent default part. And what I want to do instead is call my add to do function that we saw in the previous slide. Also on line 13, we've got two-way data binding. And so that says whatever the value of to-do text is right now, that's what I want to display in the input. But if the user changes it, I want to update that variable to match. So that is really convenient and saves me from having to write special event handling code to take care of that like I would have to do in React. Then down at the bottom, this is where I'm going to display all of the to-dos. And we see that Svelte uses a mustache style kind of markup for conditional logic and iteration. And so here we've got an each. And so I'm saying I want to loop through each of the values in the to-dos array, and I'll refer to them as just to-do. And for each one, I want to render a to-do component. And remember, I said I need to pass a prop to the to-do component, which is called to-do. So line 20 is an example of a shorthand method of passing a prop. I could say to-do equals curly brace to-do curly brace, but when the name of the variable and the name of the prop are the same, Svelte lets you make it more compact like that. Then I'm setting up some event handling. So remember those calls to dispatch that we saw back in the to-do component. if I dispatch a delete event, then line 21 is going to handle that. And I'm telling it what to do if I receive that event. Call the delete to do function and pass it the ID of the one to delete. Similarly, for the toggle done event, I'm listening for that, and I want to pass the whole to do object to toggle done. Finally, we've got a little bit of CSS, but really the only interesting thing here is on line 11 through 15, I'm saying I don't want bullets in front of the list items. Okay, so that's all there is to that app, but this covers a range of interesting features in Svelte, I think. So this slide is really kind of a mini rant from me about why I prefer the Svelte kind of markup for conditional logic and iteration. So I'm going to fly by this for now in the interest of time. You can check out the slides later and read my rant. But let's review some of the top features of Svelte. So the first thing is that it's really fast. And so if you go to the website that I have linked there, there's a comparison of different web frameworks on performance, and you can choose the ones that you want to compare, and you'll see that Svelte is very fast compared to the others. It gives you a very small bundle size, and I'll go into more detail on that in a few slides here. File-based component definitions, that means that you define a component in one file that is a combination of JavaScript and HTML and CSS. The CSS is scoped by default. So if I say that a button should be red inside my to-do component, that doesn't mean that all buttons in the application are red. I'm just describing styling for that one component. But sometimes I do want to have global CSS that affects everything, and Svelte gives me a clear place to put that global CSS. Component state management within a single component is really easy because it uses the Svelte concept of reactivity. And so an example we saw of that was my to-do text property inside the top component. And we saw how that if I change the value of that, anything that uses it is going to react to that change. We also saw a couple of reactive statements with the $: syntax that says, if anything I reference in this statement changes, I want to re-execute this statement, maybe compute new values of variables. We saw an example of two-way data binding on that input where I said if the user changes what's in the input, it should update the value of to-do text to match. We saw an example of built-in animation with that fade transition that was so easy to just import and attach it to some HTML element. And then the final thing here is easy state management across components using stores. And we haven't seen that yet, but I'll cover that in a few more slides. So digging in a bit more detail, the small bundle sizes. So one of the benefits of Svelte is that the code you get when you bundle everything in the app is much smaller than with other frameworks. And so I encourage you to go out to the website I have linked there, where you can also compare across different frameworks. And so this is not a to-do list kind of application that they're comparing. They came up with requirements for a more real-world application, and then different teams have implemented that using many different web frameworks. And you see some of the results in the blue boxes at the bottom. So if you bundle everything up into just a single bundle, and that has to be downloaded to users' browsers, what's the size of that when you gzip it? And you see that Svelte is incredibly smaller than the other options. Also, on the lines of code that you have to write to implement the functionality, there's a lot less to do in Svelte. File-based component definitions. So in Angular, when you implement a component, you do so by implementing a TypeScript class. In React, you can do that as well, but you can also define a component just with a JavaScript function. In Vue, at least in Vue 2, you define an object literal that has certain properties on it, like data and computed and many others. But Svelte doesn't really have any kind of JavaScript container like that that is used to define a component. Instead, it's just a file with a .svelte extension that happens to have the three parts that we saw. There's a script tag for the JavaScript, there's your HTML, and then a style tag for the CSS. So you don't have to surround it by any kind of JavaScript container, and I kind of like that approach. I mentioned that CSS is scoped by default to the component, and so I wanted to mention how that actually works. So what happens is that the Svelte compiler looks at all the CSS in the style tag of your component, and it generates a hash from that. And that hash is used to add a CSS class name to all the elements that it outputs when it renders that component. And so the name of the class will be Svelte dash, and then that hash. And so that is how it's able to make it so that if you say a button should be red in the to-do component, that's not going to affect anything else because no other component is going to have that same hash. Well, actually, technically, it could have the same hash, but that would only happen if it contained exactly the same CSS, in which case you wouldn't care if it used the same styling because it is the same. I said that Svelte gives you a clear place to put global CSS. And in a Svelte app, you put that in public/global.css. And if you're using SvelteKit, it's in a slightly different place in the source directory in app.css. Easy component state management using reactivity. So what we're after here is we want it to be the case that the top level variables in my component represent my state. And if I change their value, my component is going to update to show me the new value. And so in the first white box here, we have absolutely the simplest example of this that you could come up with. It's just a counter component. And so my state is in the variable count. I've got an increment function that bumps it up by 1. Then down in the HTML, I'm showing you the current value of the count, and I've got a button that you can click to increment it. So the increment function will be called. And because it changes the value of count, that's going to cause that div tag to update what it's rendering. So very simple. It's just a variable. If you change it, the HTML will update. There's one exception to this, and that is that if you want to update the value in an array, Svelte needs some help knowing that it changed. And by help, I mean you need to assign a new value to the variable that holds the array. And so earlier we saw an example like the first one where I concatenated something to the array, which creates a new array, and then I assign it to that same variable. I also could use the ... syntax, the spread syntax to create a new array that has my new value at the end. I don't really like either of those approaches though, because they're inefficient when it's a large array because it's going to build a whole new array. But what you can do instead is the trick at the bottom where you push a new value onto the array, which doesn't build a new array. And then you can just assign the variable to itself. So looking at that, you'd think, well, that can't have any effect. But actually, it does have an effect for the Svelte compiler because it's just looking to see, do you assign something to the variable? And so that's a trick that I often use to let Svelte know in an efficient way that I've made an update to a variable. And I often put a comment after that line to say triggers reactivity. So I remember why it was that I did that. We saw reactive statements with the $:, which is also called the destiny operator. And so you add that as a prefix on any top level statements that you want to repeat if anything used in that expression changes. And so we see an example of computing the average. And so if the count changes or if the total changes, I'm going to recompute the average. It's also useful for debugging if you just put it in front of a console log, because that says if the value of count changes, I want to output its value again. So great for debugging. You can also put the $: in front of a block of code to rerun the entire block of code if anything used in that block changes. And you could put it on an if statement so that if the value of the if statement changes, if the condition changes, then you'll re-execute the body. Here's a really interesting example of those reactive statements that is computing a loan amount. And so I've got an interest rate, the amount of the loan, the length of the loan, and I want to know what my payment is going to be. And this is the entire application. Again, think about spreadsheets and these being formulas in a spreadsheet. So you see how line 7 is going to recompute the number of months if the number of years changes. And line 8 is going to recompute the monthly interest rate if the interest rate changes, and so on for the rest of them. Then looking at the inputs on lines 18, 21, and 24, they all have a bind colon value binding to a certain variable. So on line 18, if I change the loan amount, that's going to cause other things up at the top to reevaluate. So loan amount is used on line 9. That's going to change the numerator. But because the numerator changed, that's going to trigger line 11 to recompute the payment. So let me jump out to the browser and demonstrate this. I'm running this inside something called the Svelte REPL. So this is a place where you can type in Svelte components and JavaScript code and test it out in the browser without having to download or install anything. And so this is that same code we were looking at. I've got a monthly payment of $843, but if I bump up the interest rate, that changes right away. And if I decrease the loan, the number of years, that increases the payment, or I could increase the duration of the loan, come up here and change the loan amount. Okay, so to me, this is some amazing code. So I invite you to try implementing the same thing in any other web framework you're familiar with and see how much more code you're going to have to write than what you're seeing here. Okay, state management across components is usually done with stores in a Svelte app. So a store is kind of a publish-subscribe mechanism where components can subscribe to a store and know that if the value ever changes, they're going to get notified and they have a chance to update what they're rendering. Often you just define your stores in a file like stores.js and then import them wherever they're needed. But there's other approaches that you can use to be more specific about where the store is accessible. There are 4 kinds of stores you can create. They can be writable, which means their value can change during the duration of the app. They could be readable, which means that your components can't change them. And actually their value can change. It's just that the store itself is responsible for what the current value is. Then a derived store can combine values from multiple other stores to compute new values. And then finally, a custom store is like the others. It's just that you're more in control of the API that is used to make changes to the data. So with a writable store, you can set a new value anytime you want by calling the set method, or you can call update and pass it a function, in which case you'll be given the current value and then you return the new value. So any component can make changes to the writable store, and then the others that are subscribed to it can update in response to that. So here's what the syntax looks like for defining a writable store. So you just need to import the writable function from svelte/store, and then you call that function and pass it the starting value of your store. So you can imagine here what I want is an array of objects that describe dogs. And so if I add a dog to that array later, then any components that care about the dog store can update themselves. You can make this a bit fancier by calling writable and passing it a few more things. So in addition to an initial value, I can pass it a function which can be asynchronous that will be passed a set function, and then it could do something fancy like invoke a REST service to get data. So the REST service might pull data from a database, and then I get that data back, and then I call the set function I was given to put that into the store. So this is going to get triggered as soon as some other component subscribes to this store. And then if I need to do some cleanup, I can return a function, and that'll get invoked whenever the subscriber count goes to 0. So that's the fancy way, but most often in the applications I've worked on, what you see in the first example of the dog store is what I end up doing. So to subscribe to the store, you can do it the long way or the short way. And why would you do it the long way if you can do it the short way? But the long way is just showing that you can explicitly subscribe if you want, and you can pass to subscribe a function that you want to execute whenever the value in the store changes. And then subscribe will return to you an unsubscribe function that you can manually call if your component gets removed from the DOM or destroyed. But typically you would do it the short way, where all you do is you import a store that was defined somewhere else. And then if you want to refer to it, you just put a $ in front of the name. And so Svelte will automatically subscribe you to that store just because of the $. And when your component is removed from the DOM, it'll automatically unsubscribe from that store. So it's absolutely the easiest way to do state management that I've seen in any framework. So should you use Svelte? Well, many of you are probably aware that we have several OCI projects that have used Svelte. But one thing to consider is the popularity of the framework. It's easy to say that Svelte is currently less popular than Angular and React and Vue. And so going along with that, it's not as easy to find developers that already know it. But I would say it's very easy to learn, and there's less to learn than with some of the other approaches. And so I don't see that as a huge barrier to entry. Because of its age, lack of age compared to the other frameworks, there are fewer component libraries out there to pick from, but there are plenty out there. So for example, if you wanted to use material design, you can find Svelte libraries that support that now, and more are being added all the time. If you're used to working in React, one thing that you're used to is the idea that a component can split up what it renders into separate functions that just return bits of JSX. And that's a thing that's not possible in Svelte. Svelte component has just one chunk of HTML. And so to get the same kind of division of work in Svelte that you would get in React, it would encourage you to break your components up into multiple .svelte files, which has its own pros and cons. There are a lot of tools related to Svelte. So there's a VS Code extension for Svelte. I mentioned Svelte Kit, which is still in beta, but probably won't be in a few more months. The Svelte testing library is something you can use in conjunction with Jest for writing unit tests for your Svelte components. Storybook is a tool that I like to use a lot. It's great for demoing the components that you've built or manually testing a component in isolation from the rest of your app. And then there's Svelte Native that you can use for implementing mobile apps in Svelte. And this is not something built from the ground up for Svelte. Instead, it's built on top of NativeScript, which is a very mature platform for building mobile apps. You can use that with other frameworks too. So you can use NativeScript with just plain JavaScript or with Angular or Vue or React. And now you can also use it with Svelte. There are a lot of topics that I didn't have time to cover today, but here's a list of some of those that you might want to look into if you want to dig further into Svelte, and all of those topics are covered in my book. There is a talk given by Rich Harris that I highly recommend watching if you have any doubts about what are reasons why you should consider Svelte. He covers that quite well in this talk, and he also goes into a lot of detail about why he feels that using a virtual DOM is not a good decision and why he chose to not use it in Svelte. Then there's the Svelt homepage, which has a really good tutorial that you can walk through. Lots of documentation and examples. You can find a link to the Svelte REPL there, and then a link to Sapper, which is the predecessor to Svelte Kit. Svelte Kit currently has its own website at kit.svelte.dev, which has good documentation on what they've put in place so far. There's the GitHub repo for Svelte, Svelte community for finding out about meetups and other Svelte resources, and then a Discord channel where you can talk to other people about Svelte. So my conclusion is that I think Svelte is a really good alternative to the other frameworks. And the bar graph you see here is just my personal assessment of how I feel about the developer experience of using these different frameworks. So starting on the left, you could implement a web app just using DOM functionality and not using any framework. But that's not a great developer experience. You're taking on a lot of responsibility for yourself to get things right. Angular certainly improves on that in my book, but I really feel that I'm much more productive if I'm using React or Vue. I feel like Angular tends to be pretty verbose compared to those. And then I think Svelte just takes it a step further with the things that we've talked about here, things like treating top-level variables of a component as its state, so I don't have to do anything special to manage state within a component. And then what we saw about stores, about how it's just a very simple pub/sub mechanism. And by using that $ syntax, I can just refer directly to a store and know that if any other component changes it, I'm going to update. So all of that to me gives Svelte a really good developer experience. when it comes to user experience from using an app developed using any of these approaches, I don't really think there are any significant differences between them. However, you might say that because Svelte makes it so easy to add animation to your components, you might end up doing that a bit more freely and deliver a better user experience because of those animations. So I encourage you to check out my book, which goes into a lot more detail than I could in this talk. And it looks like we've got plenty of time for some questions if anybody has questions. Charles Sharp asked a question about whether there's a St. Louis Svelte community, a user group or anything like that. And there's not anything like that. I've seen a lot of groups like that with a narrow focus pop up over the years, and then they don't last very long, and then they tend to fade away. And so I think it's probably more advisable to just have a bunch of talks related to Svelte at a JavaScript meetup. And there are a couple of those in the St. Louis area. And so I'm hoping that once we start face-to-face meetings again, that'll be something that I'll jump into. All right, so with the time remaining, does anyone have any questions about Svelte or any observations?
Well, Mark, you had a slide about auto registering a component sort of thing. If you want to go back to that one.
Yeah.
Yeah, auto subscribing. Yeah, I didn't remember the one. So option 2 uses a $sign to show that, right? Auto subscription shorthand.
Right.
But I'm not seeing the dollar. Oh, it's in the comment. Okay, that's what I missed. The comment at the bottom.
Right. Yes. Yes.
Got it.
Oh, here's another question. Are there any impacts on search engine optimization? So remember near the beginning when I was talking about some benefits of SvelteKit, I said that if you want, you can tell SvelteKit to generate a static version of your app where the HTML is generated ahead of time. And so that can be good for search engine optimization or SEO. Of course, Google does crawl web apps and visit the pages in it and end up invoking the JavaScript code. Maybe that's not quite as good SEO as you get if it's truly a static site, but I would say that the impact on SEO from using SvelteKit is a good one because you have the option to tell it which pages in your app are static. And then another question, how much difference is there between SvelteKit and Sapper? So I delayed looking into SvelteKit myself for a while because there was a lot of churn, but it has really settled down recently. And so about a month ago, I dove into it and I was surprised to see just how similar it was to Sapper. To me, it seems like all the same functionality is there. It's just some things were named slightly differently. And so I feel like if someone were to read about Sapper in my book, they'd really have a leg up on learning SvelteKit. But because I think SvelteKit is going to be out of beta in the next few months, I feel like if you want to build an app that won't be released for the next few months, I think I would take the chance and just jump into using SvelteKit now. All right, well, thanks everybody for watching today, and definitely let me know if you have any other questions about Svelte.